Welcome to 11.8. Surface area and volume. We've done those before, but now we are looking at spheres. We are looking at baseballs and softballs and all kinds of cool solids, three-dimensional solids. So what's the definition of a sphere? Well, it's the same definition that we typically give for a circle. Because normally we say that the definition of a circle is it's all points that are equidistant. But wait a second, the definition for a circle needs two different things. Not only that each of the points are equidistant, same distance from a particular point, but for a circle, it also needs to include that all these points are in the same plane. That is, they are coplanar. So a circle, two-dimensional figure, has two components to that definition, whereas a sphere only has that one component, which is that it really is all of the points that are equidistant from a particular point, not only in this plane like you see, but also as is represented in this oval here. This radius from the center out to the circle here is the same distance in actuality as what is being represented here from the center out to the front of the sphere, or out to the back of the sphere there. Okay, so this is a two-dimensional representation of a three-dimensional object. All of the other definitions, we are familiar with that. A radius goes from the center out to the sphere, same as with a circle. Chord is any segment that goes from sphere to sphere, anywhere in that sphere. And then a diameter is a chord that happens to go through the center. So any chord that goes to the center will be called a diameter. And again, think of this three-dimensional, and everything is still true, similar to it as for a circle. Now, what are our formulas? Let's back up a little bit and remind ourselves of what we've been through so far. We've already looked in this three-dimensional. We've already looked at prisms and cylinders. Remember, those guys had two bases, and those two bases had to be congruent and parallel. And we did the volume and surface area for those guys. And then we did the pyramid and cone. And here's the volume equation for that, and surface area equation. Remember, for those, they have only one base. Now we're looking at a sphere. And sphere, as you can see, is really simple. You only have two equations there to wrestle with. So let's do the volume first, and then we'll do surface area. The volume is the equation for the volume of a sphere is 4/3 pi r cubed. When you have a number raised to the third power, the exponent is 3. We call that cubed. And you know that for volume, you want a cubed units anyway, so that tips you off. Hey, it's got a third power. That's going to refer to volume. Let me give an example of how to solve for the volume of a sphere. And here is our soccer ball, which of course is a sphere, and the diameter of this soccer ball is 9 inches, they tell us. So therefore the radius is going to be half of that, which would be 4.5 units. And now we plug that into our equation, 4/3 pi r cubed. Simply plug in the 4.5 in for the radius. Now with your calculator, that's right, I forgot. I wanted to explain to you how to do this with a calculator. And let me run over and get a calculator real quick. All right. Thank you for your patience. Here we are, and we have a calculator. So let's figure out how to turn this thing on first of all, and let's figure out how to cube something. So I want 4.5. Well, first of all, let's do the 4/3. No. Let's do the cube first. Let's do the cube. To do cubed, what you do, let's say we want 4.5 and I want that cubed. You could, if you wanted to, you could simply say times 4.5 and then times 4.5 to get your number. Or, what I think is easier, remember when you reset the calculator, always hit the C button twice. What's easier is to do 4.5 and then, where to go on this calculator? Where is it? This is squared, right? Oh, there it is, there it is. On this calculator, you'll use this button, the exponent button. So first you put in your base, that's your y, and then you push the button, and then you do 3, that's your exponent, and then it equals, and there's your number. That was the same number as we did before. Okay, again, so double press the C button to clear it. 4.5, let's do 3. Let's do 2. 2 to the third power should be 8, so hit the 2 button and your exponent button, and then the 3, and then equals, there it is, 8. Okay, and then you guys know how to do the rest of this. 4 divided by 3 times pi. Again, make sure that you hit the pi button on that, and then times, and then 4.5, and then your exponent button, and then 3, and then equals, and that'll give you your entire answer there. So in terms of pi, if you did not plug in the pi, then it would be 121.5 pies, or not, yeah, I guess it's pies. Or if you use the pi button, then you get that as your answer. And once you rounded it to the nearest 100. Okay, pretty simple, pretty simple. Let's then have you do example number 1 here in your notes. So draw me a sphere. Do that by drawing a circle and then draw an oval in the middle of it. And in the front is a solid line. In the back, where it's kind of invisible, where you cannot see it, make that dashed or dotted line. Okay, and then draw your radius coming from the center out and identify that as 5 yards. All you have to do, there's only really one measurement that you need from a sphere, that's the radius, and then plug that in for your equation for the volume. Okay, so go ahead and pause the video and do that. Do not just keep on listening to me. Make sure that you do those calculations. Let's look at now a new concept for us, hemisphere. You've heard of the northern hemisphere and the southern hemisphere of the Earth. What that means is a half of a sphere. Half of a sphere. So this plane would be cutting through the center, and anytime it goes through the center, it's going to create a hemisphere. And so if you were to go across here, that would be a diameter. And so this is a hemisphere up on top, the yellow, and then the orange, that's around the sphere that's being cut by this plane, is a great circle. Or on the Earth, you call that an equator. The equator is the ring around the center of our Earth. And of course, our center meaning between the north and south poles. Okay, so let's apply that information to this particular problem. And here they want us to find the volume of a composite. Composite. I think we've used that term before, but that means taking more than one shape that we're accustomed to and combining them together. So this is a composite solid in that we start with a cylinder and then they bore out this hemisphere out of the cylinder. And so how would you find the volume of this particular composite solid? You would take, first of all, find the volume of the cylinder, find the volume of the cylinder, and then subtract from that the volume of the hemisphere. And you can see here that the measurements they're giving to us are that this radius is 2 inches, And since that is also the radius of this circle on top, and this is a hemisphere, therefore each radius on this hemisphere is going to be 2 inches, so therefore also the depth coming down the hemisphere into the cylinder is also going to be 2 inches there. So radius of 2 for both the cylinder and also for the sphere. And so the volume of a cylinder, you know, is pi r squared, that is the area of the big base, times the height. And then we subtract from that the volume of the hemisphere. And so the volume of the sphere is 4/3 pi r cubed, but we want the volume of the hemisphere, which is only half of a sphere, so that's why they multiply this times 1/2. And so there's your equation. And notice that the only variables here are r, that is your radius, and then the height. And as we talked about, that height of the cylinder is the same as the radius, happens to be same as the radius of the hemisphere. So you plug in your 2 for that. Okay, let's do a problem of your own here. And I wish there was a way that you could just read this yourself and figure it out on your own. But let me go ahead and, lest you say, oh, I don't know how to do it, and you gave up and you roll over and play dead, let me hold your hand and walk you through this. A solid consists of a hemisphere, so you're thinking, okay, that's half of a sphere, of a radius 1 meter on top of a cone. Okay, here's a cone with the same radius and a height of 5 meters. So here's what it looks like. Ice cream cone, basically. And so here's your cone upside down, and that matches the radius of the cone, matches the radius of your hemisphere. And so when you find, in order to find the volume of this composite solid, the volume of the entire volume is going to equal, and that's my symbol for hemisphere, the volume of the hemisphere plus the volume of the cone. Makes sense, doesn't it? We just break this up into 2 separate pieces, and let's find the volume of the hemisphere up on top here, and then let's add that to the volume of the cone. So the volume of the hemisphere uses the volume of a sphere, 4/3 pi r cubed, and then because it's a hemisphere, we only want 1/2 of that. And then we add that to the volume of a cone. Remember the volume of a cone? Well, first of all, the volume of a cylinder is the area of the big base, pi r squared, times the height. That's for a cylinder. And then for a cone, remember a cone is 1/3 the volume of a cylinder. So you put the 1/3 on top there, or add it to that, or combine it with, you're actually multiplying, you know that. Okay, so plug in your numbers that you have into here and calculate that out. Be real careful with your calculator. Do not round. This should all be one motion within your calculator at one time, so you're not having to round. All right, let's look at surface area. So please do that. Do that. Don't listen to me until you've gone back and done that. Surface area. Surface area of a sphere is really simple. All it is 4 times the area of a circle. That's interesting. And that makes sense, though, when you think of a baseball. When you look at a baseball, have you ever noticed that it has these stitchings here? And if you were to undo the stitchings, then you would realize that, hey, this is kind of like having 4 different circles there. So hopefully that will help you to remember that in order to find the surface area of a sphere, it's 4 circles that cover a baseball. So here is your baseball, and if you were to take off these stitchings, it would be approximately 4 different circles. So an area of a circle is pi r squared. Multiply that times 4. That gives you the surface area of a sphere. So to find the surface area of a sphere, all you have to do is plug in the radius. So it's 4 times pi r squared. Pi r squared is the area of a circle. And so once you know the radius, in this case it's 8, just plug that in and square it. Don't forget to square it. And then multiply that times 4 pi. And then round that thing off. In this case, they're rounded off to the nearest hundredth. Okay? So you do that on your notes here. And notice that in the previous problem, I had you round to the nearest hundredth, and I'm also having you, with number 3, round to the nearest hundredth. But then when we get down to number 5, before I forget, when I say round your answer to 2 decimal places, you understand that 2 decimal places is the same thing as rounding to the nearest hundredth. 2 decimal places is the hundredth place. So I'm really asking for the same thing with those different statements. So now you're doing number 3. The diameter of a sphere is 40 feet, and you want to find the surface area of that guy. So you do know that the equation for the surface area of a sphere is 4 times the equation for, or the area of a circle. But they gave us the diameter. Did you notice that? So be careful. Make sure that you turn that into the radius. So you know that the diameter is equal to 2 times the radius. So plug in 40 here for diameter, and then solve for the radius. So once you've determined the radius, then you can plug that into your equation for the surface area of a sphere. Let's look at another example here in your book to get you ready for your next question. Here they tell us that the surface area of the sphere is 20.25 pi centimeters squared. So remember, how many centimeters squared is this? It is 20.25 pi centimeters squared. So that is a number. In fact, that's a perfect number because it still has pi there. Whereas if you were to multiply 20.25 times pi, then you'd have to round it. So that's a nice clean number, and that is the value of our surface area. And they want us to find the radius. So we start out with the same equation that we had before. Surface area equals 4 times pi r squared, and we plug in what we know. We know that the surface area is 20.25 pi, and then bring down the rest of the formula. So now this is an equation where the only variable is r. So now I can solve this equation for r. And how do I do that? I do that by dividing both sides by 4 pi. I want to get rid of the 4 pi on the left-hand side, or right-hand side. I want to move it to the left-hand side. And when I do that, then I have pi divided by pi. That is 1. So that cancels out. It goes invisible. And then 20.25 divided by 4 will give me this number. And that equals r squared. In order to get r, of course, I just take the square root of both sides. The square root of r squared is r, and the square root of that number